Hello. This is Group 5's testing of chatbots and their ability to solve geometry questions. For our selection of chatbots, we chose ChatGPT, DeepSeek, Gemini, and Claude. These 4 chatbots were tested on solid geometry, Euclidean geometry, trigonometry and geometry, and coordinate geometry. The scope of these tests covered mathematical interpretation, computational accuracy, conceptual understanding, error handling. The categorical partitioning of tests was done via the types of geometry problems. The testing equivalences were to see how chatbots could handle invalid cases as well as the correctness of their answers. Our boundaries beyond the lower were unsolvable or contained error, lower boundary was simple problems, middle boundary was medium difficulty, upper boundary was complex problems, and the beyond the upper was undefined solutions. For testing the capabilities of each chatbot, models for test cases were designed for each geometry problem type. There are 3, context, input, and output classification trees. Here we have solid geometry's context classification tree. Models like this one had 3 levels of nodes to them, which specified the conditions of the model and the possibilities for the test cases. Likewise, there are Euclidean, trigonometry, and coordinate context classification trees. The input classification trees specified the kinds of inputs or problems that would be constructed for the prompts given to the chatbots. They included the types of problems for the categories, variables, and more. Output classification trees were how the outputs of the chatbots were judged and validated. The 3D decision table is the collective of the context, input, and output models, which helped with the complex decision-making scenarios, along with the possible variables. Test cases were designed based specifications of the models. Here is an example of solid geometry's test case, which outlines a test case with the ID, chatbot, description/context, input/prompt, output, expected output, and the result of whether or not the chatbot passed the test case. Solid geometry tests judged how chatbots could solve problems with different shape types, calculations requests, data quality, dimensional magnitude, and formatting. Tests of lower complexity judges it solving simpler problems, then longer more complex problems at a medium complexity, and finally the advanced questions that could even have missing variables and undefined solutions. Euclidean test case had the same format for test cases, and was also designed to judge on testing different shape types, calculations requests, data quality, dimensional magnitude, and formatting. Its lower complexity testing tested basic geometric problems that judged the chatbot's ability to process 2D geometric principles. The medium complexity tested the missing data, coordinate-based reasoning, and application of geometric definitions. High complexity involved problems with contradictions, malformed inputs, and edge conditions. Trigonometry followed the same test case format, with ID, chatbot, description, input, output, expected answer, and results. Its tests judged the coverage of a chatbot's abilities to solve different trigonometry and geometry, how it handled differing levels of solvable problems, error detection, and complex problems in text. These were reflected in the lower, medium, and high test case complexities. Here is an example of coordinate geometry's test case, and coordinate geometry's tests, looking at a chatbot's ability to process standard and key operations, instruction complexity, variations in inputs such as decimal values and identical points, geometric transformations, and responsiveness. The low complexity of the test's basic coordinate geometry problems, while medium complexity focuses on problems with multiple steps. The higher complex problems involved test cases with undefined, conflicting inputs, or complex computations. Now, after carrying out these test cases on the 4 chatbots, we can see the results of how many times the chatbots passed for each geometry category. With solid and Euclidean geometry, DeepSeek had the highest amount of success while Claude underperformed for solid and ChatGPT for Euclidean. Trigonometry saw Gemini able to correctly answer all of its problems, but Claude once again failed more than half. For most of its test cases, each of the chatbots were able to correctly answer coordinate geometry problems. Here we see the costs of running each chatbot, just price per character, pricey for college students. Looking at the results, LLM-based chatbots perform well on basic geometry problems with clear inputs but show inconsistent behavior on moderately complex or incomplete questions, sometimes making unsupported assumptions. These inconsistencies, more evident in API responses, highlight the need for human oversight due to unreliable handling of edge cases. In conclusion, the LLMs often underperform on geometry problems compared to their web-based counterparts due to differences in system prompts, model tuning, and access to enhanced tools or reasoning engines. Official chatbot websites typically integrate hidden optimizations, like symbolic math tools or updated model versions. That improves accuracy but isn't available through the API. For precise mathematical tasks, developers should supplement API use with custom prompts, validation layers, or traditional math tools to ensure reliability,